Hi class. I noticed on the latest quiz that a couple people made the same mistake in working with constants, and so I wanted to give sort of an explanation of how that mistake can arise and how you avoid it. So the issue here is when we're solving, it's really what I should have written here is working with constants when solving for explicit functions. So we're not going to solve any differential equations in this video. We're just going to assume that we've already gotten like kind of an explicit representation of y, but then we want to get y by itself. And so usually we have some constant that came from our integration constant like that. So let's look at a really simple example. Let's say we've got something like y. We did a separable equation, and on the one side we got y plus an integrating constant, and on the right-hand side we got an x plus 1. And let's say we have an initial condition, y of 1 equals 2, okay? Now, there's two ways we could solve this. Well, okay, I don't really mean that, but let's do this. Let's say I want to get y by itself, so I get y equals x plus 1 minus c. Now, in a lot of the examples that you see in the book and in class, I end up saying something like, well, that's just a constant, so I'm going to rewrite this like y equals x plus c. I'm just going to change that. I'm going to kind of absorb all of the constants there into its own thing without being really explicit about renaming things or anything like that. So there's kind of two different ways that you could write that. And I'm going to show you now that these are actually equivalent. So if I plug in the initial condition, so plug in initial condition, then on the left, I'm going to draw a line here. On the left, I get 2 equals x, 2 equals 1, because I'm plugging in x equals 1, plus 1 minus c. So that gives us c equals 0. And so then our whole thing would be our final answer, our final explicit form of y would be y equals x plus 1. So now let's do the same thing on the other side, and we plug in 2 equals 1 plus c, and that gives us c equals 1. And then y equals x plus 1. So we see that the c's, we got different values of c, okay? But our final answer was the same, which is really the point. So when I say I'm going to combine my constants into one, it's because I don't really care what the letter c equals. I just want a placeholder that's going to get me to the final answer, okay? So that's an example of the correct way of sort of being loosey-goosey and combining your constants. Now, let me give you another example of how you can do it wrong. So I will put here wrong way below so that it's really clear. All right, so the example that we have here is now going to be 1 over y. So, on the left-hand side, we solved and got 1 over y plus an integrating constant. And then on the right-hand side, we have an x. So I guess I'll point out here that when you do separation of variable or separable equation and you have an integral on both sides, you actually get an integrating constant on both sides from both integrals. But you only have to put it on one side because they can get connected, smushed together just the way we did it above. Okay, so we're sort of always doing this when we solve separable equations. And then I'm going to take the same initial condition, y of 1 equals 2. Okay, so I could solve this. I'll solve this the right way, and I'll say 1 over y equals x minus c. And then I will flip, and I get y equals 1 over x minus c. So actually now, this is the wrong way. I can do it like y equals 1 over x minus c, okay? And so this is what some people were doing on the quiz. And I think that maybe you were thinking that like 1 over y equals x minus c, and then that you could do 1 over y, or no, sorry, just y. When you flip it, you get y equals 1 over x minus 1 over c, and then you could just combine all of that into a c. Well, that's not how reciprocals work. And we'll kind of see why right here. So if we solve the initial conditions, if we plug in the initial conditions, then we get 2 equals 1 over 1 minus 2. Oops, sorry, not 2. 1 minus c. And that gets, we can cross multiply and we get 2 times 1 minus c equals 1. And then we get negative 2c equals negative 1, and c equals 1/2. Okay, good. That's what I had in my notes. And so then our final answer ends up looking like y equals 1 over x minus 1/2. And then if I do it this wrong way over here, if I plug in my initial condition, I get 2 equals 1 over 1 minus c, and then c equals negative 1. And so our final answer would look like y equals 1 over x plus 1. Okay, and these are obviously not the same. Because you can see this is a vertical shift of the graph of 1 over x, right? This is 1 over x shifted up 1, and this is 1 over x shifted to the right. I think it's to the right by 1/2. And so you could even see that before we plugged in the initial condition, that this and this are obviously not the same. Okay, so like I could graph this to be really explicit if I wanted. So 1 over x is like this, right? And then if I shifted up 1, remembering when you did in high school algebra and you did all of your shifts, then you shift this up like this, right? Something like that. And then this one would be, so this is 1 over x plus 1, and this is 1 over x minus 1/2. So at 1/2, we shift it over here. And like this, something like that. So you can see they're not the same is the point. So you might be thinking, well, how do I tell when it's the right way to combine it and when it's the wrong way? Well, you just have to make sure that you're doing your algebra correct. So for example, the algebra here was bad algebra. And up here, I didn't have any algebra errors. So I guess my answer is don't do it wrong, right? But what I combined here was only constants. So I can always, as long as I'm doing my algebra right, I can take the constants and combine them together. Okay, so let's go back to what the quiz problem was. And so we had a separable equation that ended up, we solved it and we got something like negative 1 over y plus c equals e to the cosine x. So in order to get y by itself, first you have to subtract the c. So negative 1 over y equals e to the cosine x minus c. And right now, the only way I could change this constant, the only really obvious way I could change it, is I could say a plus c, because I could take the negative 1, negative c, and combine that into a positive c, and it doesn't matter. That's all constants over there. And now when I do the reciprocal, I get negative y equals 1 over e to the cosine x minus c. But I have to flip everything together because that's how algebra works. And then if I do the negative, then I can do y equals 1 over and put the negative on the bottom, and that changes the order of the subtraction. So we do c minus e to the cosine x. So that is the correct way to do the constants in this particular problem.